Welcome back to Summarize Science. Today, we're looking at a huge leap forward in generating 3D human animation just from a text description. While AI for generating images and video has exploded, creating realistic 3D human motion has lagged behind, especially for complex or unusual actions. To tackle this, researchers created a comprehensive framework with three key pillars: better data, a smarter model, and a tougher evaluation system. First, the data. They built a massive dataset called ViMoGen 228K, which is far larger and more diverse than previous ones. It combines precise motion capture data, like from video games, with motion extracted from thousands of real-world videos. But here's the really clever part. They also used powerful video generation AIs to create brand new, complex, and rare human motions to learn from. This means they could generate training examples for things like a knight is jousting, which are hard to find in other datasets. Next up is the model itself, called ViMoGen. It's designed to intelligently fuse the clean, precise motion from the motion capture data with the diverse, real-world knowledge from the videos. It even has an adaptive system that decides which source of information is best for a given text prompt, like whether to trust the video or the motion capture data more. Finally, to prove their model was actually better, they had to create a new, more difficult test called mBench. Older tests often focused on simple, common actions, which didn't really test a model's ability to generalize to new commands. mBench evaluates models on 9 different dimensions, including motion quality, how well it follows the prompt, and most importantly, its ability to create motions it's never explicitly seen before. And the results are pretty stunning. As you can see in these comparisons, when given challenging prompts like body surfing or climbing a ladder, the ViMoGen model creates far more plausible and accurate motions than previous methods. The other models either produce generic movements or fail to understand the prompt entirely. The numbers back this up, showing massive improvements in generalization and consistency with the text prompt. They also created a light version of the model that achieves strong results without the heavy computational cost, making it more practical for real-world use. So, let's recap the key breakthroughs here. The researchers curated a much larger and more diverse dataset by cleverly using other AIs to generate new training data. They built a more intelligent model that can combine different sources of knowledge, and they developed a comprehensive benchmark to properly measure what good actually looks like in this field. What does this mean for the future? This work represents a major step towards a general-purpose motion foundation model. Imagine game developers, filmmakers, or VR creators simply typing out complex character animations instead of spending weeks manually creating them. It could even have applications in robotics, helping robots learn to move by understanding natural language instructions. This brings us one step closer to a world where high-quality 3D content creation is accessible to everyone. That's all for this episode of Summarize Science. Thanks for watching.